Good day, viewers. You're welcome to my YouTube channel, Master David. I am Victor Adewale Adeleke. Here, our major focus is to teach you mathematics from the onset, even up to tertiary institution. If you are here to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post full materials like this, you always get notified. Okay, yeah, we are talking about calculus. I think this is an introductory class for calculus that I just made, and I'm just going to start making from henceforth. I will create a playlist on it. So I'm not really going to be able to talk about all because calculus, is a very vast topic, very, very vast, spreading through into the exponential equation, logarithmic equation, trigonometrical, even hyperbolic, and even and so on and so forth. So there are so much. It's a very vast topic. So with time, I will be just with the playlist. I will be creating several classes on it, explaining the several branches of calculus, being in differentiation and integration. So I'm going to be starting with differentiation today. Okay, first of all, what is differentiation? Differentiation is actually talking about the rate of change. Now, you can see one thing, the idea of differentiation is that we are taking a slope. Now, I think those of us that were very familiar with our geometry class in a basic 3, or sorry, basic 5, basic 6 classes, our secondary school classes, we are very familiar with this, how to find the slope of a straight line. And I think many of us are very familiar with that. Okay, now to find the slope of a straight line, let's say the slope is always change in x over change in y over the change in x. So this is the idea, change in y over change in x. So if you are changing y now, the difference in y you can see here, if let's assume this is 2, this is the Cartesian plane, for example, this is the positive line on the x-axis, and this is the positive line also on the y-axis. So if you want to get the difference here, which is the change, if you want to get the difference here, just y2 minus y1, then all divided by x2 minus x1. So this is the idea that we also stretched into calculus or differentiation per se. This is the idea that we are really going to talk about. So that's the reason why I want to use this basic idea now to prove out the information or the system of how calculus works. Now, what are we going to understand now? The next thing we should keep in heart is that, let's assume, okay, this is a point. This I already drew this out. This is a point. These are 2 points. These are 2 points. So this is a function. If this is x, note this is function of x. Those of us that did function in our further mathematics, you understand what this is. So this is representing y also. So if we are saying x, this is y. So this is x, which is y with respect to x. So this is the function. We can call in function. If you study further mathematics, we can call functions. Sorry, we can call y. We can represent y as function of x. So this is x. So if this is x, this should be function of x. Now let's assume that this is 5. Let's assume that this is 5. Now we already know that from here, this is the point of origin, which is the 0 point. Now from here up to this x-axis, we agreed that this will be increasing. So it will be going like 2, 3, 4, 5, 6. So it will be increasing. So let's assume that this is 5. If this was 5 and this is 7, we are assuming this time that this is 5 and this is 7. So if this is 5 and this is 7, automatically we know that the difference between the distance from 5 to 7 is going to be 2, because 7 minus 5 is going to give you 2. Agreed? Okay, now in this place now, let's call here. So if this is 5 now, we can say for the distance taken from here, which is this point to this point, is 2, which is the change of this x to this point. So we can call this place now, we can call it change in x or h. So we can call it change in x or h. Now once you note that this is h, or change in x, so automatically if this was 5 and this place, as I said, was 2, to get this place, all you need to do, the other way to see it is that 5 plus 2 will give you the distance, so will give you the new point. So automatically, which means that if this is x and this is a change in x or the h, the new point would become x plus, let me write it down here, x plus h. The new point will become x plus h. So that was where the idea came out from. That's the reason why they just called this whole place They just call this O place x plus h. So if this was x, this becomes x plus h. I've already explained the ideology how it became x plus h. Now, once you have noted that this was x and this was function of x, so automatically since this is now x plus h, this place here is going to be the function of x plus h. Nothing has gone wrong. We are still on track. So from here, the next thing we are going to think about is to get the slope, because the idea is that we are trying to get the slope of this curve. That is the pure idea. You know, I talked about the slope of a straight line. So now we are trying to get the slope between this curve, or the slope of this curve particularly. So how are we going to get the slope of this curve? So to get the slope of the curve, the idea that Isaac Newton now propounded was that he drew a straight line through the curve. That straight line became a secant. You know that when a line passes through a cycle, it becomes, or a curve, it's a secant line. So this is what we are having here. So this line that cuts through is now a what? It's a secant that passes through the curve. Now we're trying to get the what? The gradient or the slope of this curve. Now, how are we going to get that? So that was the idea that Isaac Newton did. He took 2 points that he took 2 points where the straight line touches the curve. So that was what he did. He took any 2 points where the straight line touches the curve. Then he assigned values to those points, which we already did, x and x plus h. Then the function of x plus h and the function of x. So what he did was that he looked for the slope between those lines. It's looked for the slope. So how are we going to look for the slope now between this curve? As simple as ABC. So just the same method of operation. The change in y with respect to change in x, that's we already know that to be slope, will be equal to, it was y2 minus y1 over x2 minus x1, which was the normal one we already knew, or we're already familiar with from secondary school. But the same thing applies here also. So it's going to be the function of x plus h minusing the function of x, then all divided by the x plus h minusing the x. So you already saw what happened there. This is x plus h minusing x. So x is going to what? Eliminate x. We are left with what? We are left with h. So the change in y with respect to change in x is equals to the function of x plus h minus the function of x all over h. But this is actually giving us the value, that's the gradient, or the gradient or slope of the straight line, not the curve. And what we are actually looking for is the gradient of the curve. So what do we do? What are we going to do? So this was where the idea of limits came into consideration. So what this young man did was that he started pushing these points very close to each other. Now you should notice he's trying to look for the gradient of the curve. So he started pushing this line through to this other point here. As he was doing that, you will notice that this line will be gradually becoming small. Which means this curve will automatically be becoming small. You can check my video, check the front of the screen. You are going to see something like that. I'm showing particularly how this thing happens. Yes, I think you are seeing it now. So with this, this is a picture of what was happening. Why that's the idea through which this young man, Isaac Newton, brought out this theorem. So he brought these points to each other, very close to each other. So as he was taking these points close to each other, don't forget that this was our h. But when he takes this line close to these other points, automatically this h becomes very, very, very small. Now, the limit that h can go is that h can never be 0, because if h becomes 0, don't forget 1 divided by 0 is undefined, which is to infinity, so it's not correct. So it's a math error. It's not possible that we have 1 divided by 0. It's not possible. So what do we do? So that was the idea that this young man made. He made sure that this h, this point, as he was taking it very close, it can never become 0. This h should never be as small as 0. That was the idea. So that was what introduced the limits. So from there we had the dy dx equals the limit as h tends to 0, which means that h should never, which is the distance or the change in x, should never become 0. It should never become. So as h tends to 0, then we have the function of x plus h minus the function of x all divided by h. This was how he propounded the theorem. This is the simple formula, or some places call it the first principle. Some places call it the first principle. So this is how he propounded it. This is exactly what will give you the dy dx. So if you are given any function, let's assume, let me see if I can use this small space here. Let's say y equals to x squared, and we are told to find the slope, the change with respect to x. Now, what do we need to note here? This also means function of x equals to x squared. Then, if function of x is equals to x squared, then function, those of us that are very familiar with our further mathematics, you can say x plus h is the same thing as x plus h squared, because the function of x plus h will also be represented. That's these two now, we are connecting these two together. So this is what is happening here. So once you have noted that, now let's just substitute it with the formula to get dy dx. Let me see how I'll be able to maximize my time and get this. Now let's see. We have limit as h tends to 0. Now what is the function of x plus h? That is what we have. X plus h all squared. Then minus, what is the function of x? That is x squared over what? H. Okay, let me see what I can do here. So limiting h as it tends to 0. So we already know that if we expand this, we are going to get x squared plus 2xh, then plus h squared, try to limit space, then minus x squared all divided by h. So what happens here? X squared eliminates out x squared. Now we have h squared here, we have h here. I'm just trying to show you a preamble or a very short way of how to do this question particularly. So this will become, as that's limiting h as it tends to 0. So if you factorize, because we have h squared here, we have h squared here. So you factorize h out, you have x plus h, yes, all divided by h. So h cancels out h. Then you can now substitute the value, because cannot become 0. So now, since you have simplified everything to the simplest form, make sure you always simplify, because maybe I will try to create another class on limits. Then you substitute the value of h now into this place, and you have 2x plus 0. So your final result becomes 2x, of which you already know that when y is equal to x squared, that is going to be the derivative. The derivative is going to be 2x. So this is how it works. Very, very simple. I just gave an example, a very short example to explain how these things works. So I will create another class again, also on this same playlist that I've started, that would provide the solutions using this particular formula. This is the formula. This is the formula. This is the formula. So using this particular formula to bring out all the questions and to solve all their problems. Almost all their problems can be solved using this method. If you have any questions, if you have questions, maybe you have questions that you want me to use this particular principle on, you can drop it on the comment section. And if you're yet to subscribe to my YouTube channel, do well to subscribe, like, and share, so that whenever I post helpful materials like this, you will always get notified. Stay tuned.